So welcome. I appreciate you joining me early in the morning. You could be, well, either at work or still sleeping, right? So I appreciate you joining me. Super excited to be here, right? This is probably my third or fourth Serverless Days as a speaker, and had a couple more as an attendee, and I can absolutely say I'm really impressed with what I'm seeing here. So I'm excited to be here today. I'm really excited actually to be speaking early in the morning because that means I can participate the rest of the day and actually attend some great sessions as well. My name's Josh Carlisle. I am an engineer on the App Dynamics team at Cisco, and I'm also a Microsoft MVP. I've been a developer now probably, gosh, I hate to say it, going on a little bit over 20 years now. Probably about a decade ago, I jumped on this fad called the cloud, right? That folks were saying that was going to be short-lived, or it was just going to be like a niche use case. And then, a couple years ago, I jumped on this other fad called serverless, right? Another thing that people said would just be in passing, right? But at the end of the day, though, the funny thing is, from a fad standpoint, sometimes you can measure when a fad is about to go mainstream by counting how many solutions there are for monitoring, right? I've been in the early days of serverless where I spent a lot of time on the equivalent of console.log, right? Or console.writeline. And now I literally have dozens of solutions that I can work with. Now, today's talk is actually vendor agnostic. I'm not going to talk about any single vendor out there, right? I'm more going to concentrate on some of the decision-making processes, right? Some of the challenges that we have with monitoring serverless. So some of the recommendations I'm making are actually coming from my time actually building and deploying serverless solutions for a couple years, right? And even some of my challenges that some of my customers have today that we run into. So we're going to keep things on the recommendation side, we'll call it, right? So I'm going to learn how to use this clicker before the end of the talk. So I want to preface this talk a little bit about kind of setting the stage of where I think we need to be from a monitoring standpoint. I think far too much these days we are spending time from a monitoring standpoint in a crime scene, right? We're looking at things after the fact. We're trying to figure out why our application just died. We're looking at logs. Hey, were there any exceptions that happened? Was there a new release? So we're looking at things from the perspective of after they've already died. Now, I like playing detective as much as anybody else. I actually started off, I went to school for criminal justice, went to the police academy. Somehow, shortly after that, it turned into the fact that it wasn't anything like Miami Vice, right? And I think from the standpoint of folks on the monitoring systems today, they come to kind of a similar realization is this is not where I want to be, right? This is not where I want to be spending my time. So ideally, at the very least, we want to be here, right? We want to be in a place where our patient's still alive. We're not at a crime scene. We're trying to save their life, right? This may mean we're in the ER. It may mean they're on life support, right? But we've gotten there early enough, right, where we can potentially make a difference, right? Bring our app back from death. At the very least, this is really where we want to at least be, right? We don't want to be in that crime scene if we can avoid it. Ideally, we want to be here. We want to be in a place where our day-to-day ops, right, where we're ahead of the game, right? We have the visibility that we need, right, to be able to kind of get some early visibility and preventative medicine, right? To be able to identify, hey, the app isn't behaving very well, but nobody really notices yet. We can fix this, right? And so ideally, this is a place where we want to be. Now, pie in the sky, we want to be in a place where we're using that time that we're saving from always putting out fires and always fixing stuff to actually build a stronger, faster version of our application. Now, I was told when I showed this slide at a previous conference that a lot of the audience didn't know what this picture was, didn't know about the $6 million man, and it made me feel really old. But I think maybe next time we'll put a picture of the Borg or something up there, right? But I think you get the drift here is that ideally we want to get to a place, right, where we're spending our time not putting out fires, but actually making improvements to the platform. But why is this so hard? Why are we talking serverless monitoring as opposed to just general monitoring challenges? Well, it's hard because we have some unique challenges, right? The status quo doesn't really work anymore, right? We don't have those servers that we can deploy our traditional agents to deploy our traditional pieces that we normally have with monitoring. They're not available to us anymore. We also have some platform limitations. Things like cold starts, things like execution timeouts. There are some unique challenges when it comes to monitoring serverless. Ephemeral compute is a big thing as well. So a lot of the traditional data collectors or traditional agents can't even be installed many times, right, on the serverless, from the serverless standpoint. And even if they can be installed, the inherent nature, the unpredictableness of that compute, whether it's going to last a few seconds or abruptly be shut down, makes it so those traditional agents won't work properly, right? And then lastly, today serverless platforms are largely highly distributed, right? There's a lot of asynchronous processes. So that adds a lot of challenges, and all those add up to the fact that we have some unique things that we need to address from a monitoring standpoint. Now, of course, there's a lot of overlap, right? There's issues that come up with traditional monitoring that overlap with serverless monitoring, but we're going to kind of focus on where that overlap is, and especially on the serverless side. So, how do we choose? How do we get from the point where we're at a crime scene to where we're actually using the powers of monitoring to actually improve our application, right? So I like to kind of base this discussion around the three pillars of observability. So from a vendor standpoint, pretty much every vendor out there is going to have solutions that are based around these pillars of observability. And they include logs, right? Logs are what you would expect. Logs honestly play a very pivotal role when it comes to serverless. I wish and hope that they become a little bit less pivotal than they used to be, and we'll talk about that a little bit. But logs obviously are a key part of observability. Then we have metrics. Metrics are time series data, right? There are data things like CPU and memory that you would expect from a metric standpoint. And then we have traces. Now, traditionally, traces, prior to the distributed world, was all about following the flow of execution through your application within your process. But as distributed applications became more mainline, the term distributed tracing became more important, and that's kind of where we're going to focus our discussion today when it comes to tracing aspects of things, is the distributed tracing portion of one of the pillars of observability. So we're going to start with logs for our discussion. So once again, if you're working with logs, in general, you are working on a crime scene. Now, I know I'm overgeneralizing this, right? There are some other things that you can do with logs. But once something's in a log, it's already happened, right? But that doesn't mean that it's not super important to understand the role of logs, especially when you're making some of your decisions on what your monitoring platform should be. So first off, logs answer the question why, right? We all want to know why something particularly happened. So we're going to get that kind of answer from logs. Logs also give us our deep diagnostic data that we need to be able to quickly find root cause. So a lot of good stuff with logs, right? But, excuse me, we also have some challenges with logs. Logs kind of become a haystack, right? So we're pulling in all these logs, we're pulling in lots of logs, so many logs that we have the proverbial needle in a haystack issue, right? We lose some of the utility and some of the advantages of logs because we're pulling in so much volume. It's one of the reasons why many monitoring projects and monitoring implementations turn into some sort of log management project as well, because it becomes an important part, and you want to make use of it, and we emphasize it heavily, but it also has challenges. Also, from the standpoint of logging, so if you're not getting the visibility you want from logs, what do? Well, you ask the developer to put in more logs, right? So one of the challenges from that standpoint is, from a developer standpoint, is that we're placing a lot of burden on the developer to increase visibility by writing more code that we have to monitor and maintain, right? And so a lot of monitoring solutions today that are SDK-based can place a lot of burden on the developers to provide you that visibility when it comes to logging. So this should resonate with some folks here, right? So this is kind of an example of maybe a typical function that we have a lot of logging in. It has things that you would expect. The I made it here, right? Kind of logs that we all have. It has some calculations, right, on the execution time. But there's a lot of logging code in here. And you might be asking yourself, how much of this code is actually providing some sort of business logic? Well, it turns out kind of very little, right? So now the developer me is not scared about writing a few lines of code. What's the big deal, right? But the dev manager in me understands that every line of code is debt, right? And it is not unusual to come to the end of a monitoring project and realize you've inherited a lot of debt without even knowing it, right? And then that debt comes at a price as well, because a lot of times from the standpoint, let's say, for example, you're just doing straight up logging or implementing an SDK. You now own the maintenance on that, and if that SDK changes, you now have to make changes from your code. So from the standpoint of getting that visibility and relying on developers, there's obviously some considerations that you need to make. You need to go in with your eyes open, making deliberate choices before you start having to go down this path. So what are my logging recommendations? So first off, once again, it's an easy default choice, especially from a developer standpoint. It's where we're comfortable writing logs, right? But really, it shouldn't be your first choice, and it shouldn't be your primary choice when it comes to monitoring your applications. They play an important role, but once again, by far, when you're relying 100% on just logging, you're in that crime scene territory. So when you can, avoid logging code, right? Avoid having to write code to get visibility into this. From the standpoint of serverless, serverless is one of the many benefits of serverless is that efficiency and that velocity, right? That you get by being able to concentrate on the code that matters to your customers, the code that matters to your business. When you're writing lots and lots and lots of logging code, lots of SD code, you're eating into that benefit that you've gotten out of serverless because you've just transferred the burden of, I don't have to maintain infrastructure anymore, to I have to maintain lots and lots of logging code. So consider ways in which you can avoid logging code. Also consider profilers. So profilers that are part of a monitoring solution can take the place of a lot of this boilerplate logging that you get. The things like, I made it here, I made it here, I made it here, or this is how long this line of code took to execute, or this is how long this method took to execute, right? And you can achieve that without having to write any code. But like folks say, there's no free lunch, right? So when it comes to profilers, make sure that whatever solution they're using is using those profilers in an intelligent way so that they're not adding some extra overhead onto your platform from the standpoint of those profilers. But once again, there's a lot of advantage to not having a lot of write any code and get some of the same benefits that you would have gotten from someone writing dozens of lines of code. So the last thing that I'll mention, and I probably harp on the whole code writing thing a little bit during this presentation, but go back and think of that function that you saw and all the code in there, and just multiply that times 100, multiply it times 1,000, or even more, right? So let's move on to metrics and insights, right? So metrics are your first opportunity to really be proactive, right? To get ahead of the game. And metrics are important because they provide really the insights into your application. They provide insights into your application's performance. And they're real time, right? So I equate metrics to hooking someone up to an EKG and seeing real time how their heart is behaving, how their heart is performing, so that you can do what you need to do to make sure that things go better, or that obviously it doesn't stop as well. But metrics have their own challenges as well. So understanding metrics can be really difficult. You would think that some of the metrics would be pretty straightforward, but consider something like CPU and memory. CPU is high, memory is high, for example, right? But what does that actually mean? Is the CPU high, memory high because you have a problem? Or is it because you're really, really utilizing your hardware really well, right? You're very, very efficient, right? Are you having latency because of a cold start? Or is it because you have an application logic issue, right? So metrics, although give you a lot of visibility, don't necessarily give you a lot of understanding. And also when it comes to correlating metrics, there are a lot of challenges. Sometimes when you have a metric of x plus y, that's okay. But x plus y plus z is a bad thing, right? So there's a lot of complexity in really understanding those metrics and how they correlate, especially when we start getting into a little bit of the distributed side of the equation, when metrics are not just a single function, but jumping all over your platform. So getting an understanding of those metrics and how they interrelate can be very challenging. So what are my recommendations when it comes to metrics? Well, almost every platform I see out there has some sort of concept of what we call a baseline, and most of them call it a baseline. Some of them have some different names for it, but a lot of the platforms I've worked with, specifically in the past, call them baselines, right? And so what baselines are is they help you get the understanding of that metric. And what I mean by understanding, I'm not talking about an understanding from high CPU is bad, right? Low CPU is good. I'm talking about the understanding from your application's perspective is what is good or bad. So that you, at the end of the day, you want to make more intelligent decisions about your application. You want your monitoring platform to help you do that. I equate it to the fact of a lot of times those metrics, we drive those off of alerts, right? If you don't have understanding of the metrics and the variations of those understanding the metrics, what will end up happening is you'll say, let's say I create a threshold saying, send me an email when it's over 5 seconds. It sounds great on the surface, but what it ends up equating to is, hey, I may get too many alerts, right? And so I get these alert storms where I start ignoring everything. Or on the other end of the spectrum, it's too conservative and I don't get alerted enough. So understanding metrics at that fundamental level help you to make more important decisions. So let the monitoring platform that you use help you in that understanding as well. Now, I bring up machine learning and AI ops. Now, I know there's a lot of eye rolls. Oh God, AI ops, that's the latest buzzword today, right? But it has an opportunity to really change how we do monitoring. At the end of the day, AI, it's all machine learning, right? And machine learning works best when you have lots of data. And what do monitoring platforms do better than anything else? They generate lots and lots of data, right? So that gives you an opportunity to actually make some intelligent decisions based on that data. So going back to the correlating metrics piece, so instead of having to sit there and understand the interdependencies between all these metrics, we can look to a platform that uses AI ops in some fashion or form, uses machine learning to find that root anomaly, to find the root cause a lot quicker, so that I don't, A, have to reach out to developers or the really, really smart people on the team that generally don't have a lot of time to tell you how these things work together. But I have the ability to then just say, hey, the platform says, out of these 50 metrics, this is really the source of it, and this is where the source of the issue is. So finding that needle in the haystack, right? And it's worth mentioning some of the AI ops stuff doesn't apply just to metrics, it applies to logs and stuff as well. Oops. Okay, going on to our last piece here with our distributed tracing. So distributed tracing actually is there to give you the big picture, right? It provides that big picture. It's worth mentioning that distributed tracing all by itself doesn't necessarily have a huge amount of value, but when you combine it with the metrics and the logging is where things really start to shine with distributed tracing. Now, distributed tracing is going to give you that end-to-end visibility. It's also, that is really important, especially in these big distributed systems that are really common on the serverless side, but also it's going to help you find the source of that issue. There are probably few folks who have worked on the serverless side that haven't spent a lot of time looking at an individual function and saying, oh, I've just spent like half a day trying to figure out what's wrong with it, and then you find out it's something upstream or downstream, right? It has nothing to do with you. So finding the source of that issue through distributed tracing is going to save you a lot of time. But at the same point in time, it's difficult, it's hard. And very often you're going to have large gaps in your distributed tracing. Now, why is that? Well, the way distributed tracing is implemented, sometimes it's SDK, sometimes it's based on logs, sometimes it's just intelligent and you have an agent that knows how to kind of inject the correlation that needs to happen. But even then, the agent needs to have support for the various frameworks. When you have these distributed applications working together, they're communicating in some fashion or form. They need to understand how they're communicating to pass that information along and kind of stitch together that big picture. And that can be very challenging. I like to represent this a little bit in the standpoint of when we're talking about this visually. Now, a lot of the platforms out there and a lot of solutions out there all kind of have a visual element to representing distributed tracing. This is a pretty common distributed application, something like an Azure function, right? And this could be a Lambda function as well, too. I generally live in the Azure functions world, but this could be applied to really any serverless solution, where we have a function talking to a messaging platform, and then we have another function listening on that messaging platform, and then talking to a database. In this case, we have Cosmos DB here at the end. But from the standpoint of the overall view of the application, right, that the bigger ecosystem that this lives in, we also have a lot of downstream. Once again, I think there's very few people who have implemented serverless solutions that haven't blown up something downstream, right? I mean, it's a fairly common blowing up a database, blowing up a platform downstream. So having that visibility into the downstream becomes really important. And also having visibility in the upstream, right? What are those inputs coming in? Where are these requests coming from that are killing my platform? And this, at the end of the day, turns into our end-to-end visibility that's really important when it comes to serverless. So think past really just the serverless portion of it and think of the whole ecosystem that serverless lives in. And that way, when you have an issue in any given point in place, you can identify what's going on there, whether it's in the function itself, whether it's downstream, or whether it's upstream. So wrapping up things from a tracing recommendation, and I know I'm harping on this a bit, avoid coding if you can, right? It's going to be a distraction. It's going to have all the challenges that I've already spoken to, but specifically in the context of distributed tracing, if you have to write code for distributed tracing, it's more than likely there will be some place in your ecosystem that you can't write code, you can't deploy code, so you're going to have a gap. So if you can figure out a way to get your distributed tracing without writing any code, think beyond serverless, upstream and downstream. Don't just consider your little serverless ecosystem from the standpoint of application monitoring. And lastly, consider the impact of monitoring silos. And why I mention this is, back a few years back ago when I was building a lot of Azure Function Solutions, big fan of App Insights, right? So I used a lot of App Insights, but I had downstream dependencies, right? So I had a lot of downstream dependencies, and when that would fail, I had to call a different team. I didn't have any visibility to that. We had different sources of the truth. It caused a lot of bottlenecks when it comes to monitoring. So consider the impact of just having a siloed solution versus having a holistic solution, or at least having a solution that maybe specializes in serverless, but is able to connect the dots with the bigger picture of your other platforms. So to wrap things up, wish you the best of luck when it comes to choosing your monitoring platform. And in the words of our famous 1970s cyborg, I hope you're able to make your application stronger and faster. Feel free to reach out to me on Twitter, LinkedIn. I'm here all day if you'd like to have any discussions. And I thank you for your time and enjoy the rest of the show.